Number 4, zinc solid is used to reduce other compounds in chemical reactions, okay? If a chemist needs a substance that is more effective in its reducing ability, which of the following species would be the best choice? Well, if you think about something that, reduces other compounds. So basically, another word for that would be, so zinc is serving as reducing agent, right? So something that is helping other substances to be reduced. So AKA, this itself must be oxidized, right? So must be oxidized. Something that is oxidized is what serves as a reducing agent. A lot of people don't really understand this concept, so let me, give it to you this way. If something were to, let's just say, let's say silver were to oxidize, and that becomes silver aqueous and electron, right? So when it is oxidized, it drops that electron, right? So the other substance, whatever that may be out there, that would like to obtain this electron, so take that electron to become reduced. So essentially, something that is being oxidized and therefore giving away an electron, well, that's technically helping the other substance to gain that electron that was released and then become reduced eventually, right? So once again, if it says zinc is used to reduce other compounds, well, that just means zinc is the one that is providing the electron, therefore the zinc must be oxidized. So the question is asking something that's going to be more effective as a reducing agent. So what's going to be even better to be able to help others to be reduced? Once again, in other words, what's going to be even better to be oxidized? What's more likely to be oxidized than zinc is? And the only answer choice you should be looking at is choice A, sodium. Now, why not the other ones? Let me take a look at it. First of all, choice D, chlorine minus. That is chlorine minus. If anything, it wouldn't want to take an electron because it already took an electron. Chlorine normally has 7 valence electrons, so for it to become chlorine minus, it must have gained that additional electron right there. So it already gained it. It doesn't want to gain any more, right? So it's not very likely to become oxidized. In fact, it is not gonna oxidize at all, right? So that's out. And if you take a look at potassium plus, okay, potassium is alkali metal, so it is normally willing to give away an electron. But if you think about potassium ion, it's a K plus. It already gave away an electron by doing K goes to K plus and an electron. It already dropped it. So if you wanted to drop even more, I mean, that's not going to work because the potassium ion, in terms of its electron configuration, right now it is in its noble gas configuration, aka super stable. You want to break it, it's going to take a lot of energy, so not very likely to happen. Same thing with hydrogen. That hydrogen looks like it already gave away an electron, so it's got no more. In fact, I mean, hydrogen only has 1 electron. You already took it off. It has no more electron to be able to even drop. So that's not it. That's why answer choice A should be correct. And if you guys think about it, the sodium atom is very, very willing to give away its electron, because, well, first of all, it's alkali metal. Metals normally give away their electrons. And secondly, well, once sodium gives away that 1 electron, it's going to become the noble gas configuration, which is going to make it very stable.